Networking is about ensuring that the flow of digital traffic between instances or services is fast and reliable where necessary, and impossible wherever it's dangerous. We'll discuss a number of traffic control tools later, but we'll start with IP, Internet Protocol, addresses. Every network-attached device, whether it's something physical like a smartphone, laptop, or router, or a virtual device like an Amazon EC2 instance, must have an IP address to identify it to other network resources. IP addresses are either assigned automatically by a DHCP server, DHCP stands for Dynamic Host Configuration Protocol, or can be manually configured at the device level. Broadly speaking, there are two kinds of IP addresses, private and public. The important difference is that private addresses, as the name suggests, cannot be reached from a public network. To explain that a bit better, when it became apparent that the number of Internet-connected devices was growing so quickly that we were in danger of running out of IPv4 addresses, network designers developed Network Address Translation, NAT, to dynamically remap IP references as packets moved between public and private networks. Using NAT, a private network with hundreds or even tens of thousands of devices could all share a single public-facing IP address, relying on the local router to send everything to the right place based on a strictly local addressing scheme. It became accepted practice to restrict all local NAT addresses to 3 limited ranges, and to avoid using any IP from these ranges in public. The reserved address ranges are between 10.0.0.0 and 10.255.255.255, 172.16.0.0 and 172.31.255.255, and 192.168.0.0 and 192.168.255.255. While this freed up literally billions of IP addresses for public use, the downside, of course, is that local addresses will make no sense in a public network. When you create a virtual network on AWS, a VPC, which is a virtual private cloud, you can choose which private network range your resources will use. Let's quickly run through the first 2 steps of creating a new VPC using the VPC wizard. You needn't worry about some of these details. We're only doing this to illustrate choosing an IP address range. We'll select a VPC using one public and one private subnet. You'll notice that according to the current default settings, there will be more than 65,000 IP addresses available to our network, all in the 10.0.0.0 range. The /16 notation tells us that only the first 2 octets, the 10 and the first 0, are reserved for network addresses, with the remaining 2 octets available as nodes. Hence, 256 times 256, which equals 65,531. Our first public subnet is restricted to addresses within the 10.0.0.x range, meaning addresses between 10.0.0.2 and 10.0.0.254, while our private subnet will exist within the 10.0.1.x range, receiving addresses between 10.0.1.2 and 10.0.1.254. Now let's take a quick look at how this might work from the perspective of a network device, in this case, an EC2 instance. We'll start the process of configuring and launching a virtual computer using EC2. The default VPC for my account lies within the 172.31.0.0 range, rather than the 10.0.0.0 we were going to create for the VPC we were just playing with. We can choose to select any one of 4 IP ranges, each used by a separate availability zone, as the host for our new instance. We'll speak a lot more about VPCs, subnets, and availability zones later. For now, though, it's enough that you're aware that devices must have unique IP addresses, and that AWS assigns IP addresses within ranges to help identify them as part of specific network segments.